Welcome back. This is Rashid here, and today we are going to talk about what kind of output files are created as after synthesis stage when synthesis is done. Okay, reports we have already looked at, and I gave you overview of the main keyword reports. The other reports I gave you idea of what is contained in different reports. I'm avoiding going into very in-depth tool specific things because you might have a different tools and reports could be different and the format of the reports could be different, and that is totally okay as long as you have understood the overall purpose of different reports and what kind of reports we need. I think that's good. Very quickly, when you're in a new tool, very quickly you will be able to learn what are the new reports. Okay, and just get all the commands that are used for report generation, and from there go to the man pages of each and get the description of what is the purpose of each report, and that will give you a good idea of what reports you can have in your flow. Again, it's always based on the debugging. What information you need after synthesis. So if you understand the core synthesis concept, what exactly are you looking for at the output of synthesis, then you will be able to find the report. Okay, so let's focus on outputs. This is the tickle file I had used to generate some of the outputs, but what I want to give you an idea of what is the general idea of different outputs, why those are generated, where those are used. Okay, so keep one thing in mind, that traditionally vendors have been giving us one synthesis tool and then another place and route and clock tree synthesis tool. Those have been different. This particular tool I'm using, Vision Compiler, it has synthesis inside and then PNR inside. So the interface is not as formal as it was before. Before, you generate outputs from here, you have a shell for synthesis, you generate outputs like Design Compiler, for example. You generate those outputs, and after that you exit. Okay, you exit and you start a new shell, a different shell for PNR tool placement and routing. And that's where you read all those outputs that you had here and you build your new database here. But nowadays, I think vendors are going with one tool which does everything, which simplifies things a lot in terms of flow, in terms of what you need to generate from here to here. But there are other tools other than PNR that might need the synthesis outputs. So let's talk about different outputs, and then we will discuss why we need those other outputs. So very first command, this is just we are writing the netlist out of synthesis. Okay, so that netlist format is verilog. So you can also use write and then say a file format blah blah, but I use rather this one. Clearly it's a verilog, right? This is just a name. I gave it a name because I want to give whatever design I have. For example, if it's a counter, I want to, because later on I will be writing out in the same folder outputs from placement, routing, CTS. So I want to make sure that this verilog netlist name that I gave right after synthesis or final synthesis, I just differentiate it from others. Okay, and then at the end I'm giving it extension VG. I can give it .v or something else too, but this says verilog gate level. Okay, so the question is, this verilog netlist that you generate out of synthesis, what is that used for? The main tool, in my opinion, is the formal equivalence check. There are tools like formal conformal or formality. Okay, and the purpose of these FEV checks, I haven't covered in my videos this thing. It may be a good point to cover this in detail and a little sample flow. Those flows are super simple, just one command line file. So the purpose is, you gave your synthesis RTL and we did all synthesis and then we created this output. So question is, what if synthesis tool did an optimization that changed the actually logic of the design? So in other words, when we run a simulation on RTL and then we run exactly the same simulation on netlist, Are both same or not? For example, what if during optimization tool has inverted an internal node logic? It's kind of invert, an additional inverter is there. So if you look at the original RTL, you have no inversion, but during synthesis you have inversion, right? I mean, synthesis tools are doing a lot of optimization. They can make mistakes. So the whole check is to make sure that our synthesis output, which is the one we're gonna take forward, and to placement, CTS, routing, then finally ECO changes and all that, and we will get that ready for GDS. For each of those stages, we want to make sure that tool is not changing the functionality of the input design or input RTO. Makes sense? So this is a separate flow that is checked after some of the major stages, like, okay, people check it after synthesis, then later on after routing, and maybe once after the very final design. Okay, makes sense? So for that we need netlist. Sometimes the DFT team, it is a separate DFT team, they're doing their gate level simulations, and they need that scan stitching information inside. So for them, they need a netlist, and it can be used there too. Next two files are floor plan files. You can save it in def or floor plan. So you don't need both. But another advantage of this one right now at the synthesis output is that next time you're doing synthesis, remember we did a power grid, we did IO terminal placement, and internal SRAM placement and all that. So in this flow, we were kind of creating everything from scratch. But when the floor plan is finalized, you don't need to create in every synthesis run. So you just want to have the very first time done, thoroughly checked, analyzed, and everything. And after that, you can create a floor plan file, .floorplan or .def. And in the subsequent runs of the synthesis, all you have to do is just sort those files. Okay. Then SDC. Okay, SDC file is it's I think stands for synopsis design constraints, not standard design constraints, which is we must have some background there with why or the reason why it's connected with synopsis. But anyway, it contains those standards timing constraint constructs. They create clocks, create generated clocks, fast path, multi-cycle paths, and all those. Keep in mind that all the constraints timing constraint that you can create in any tickle file, not every command is supported by SDC, which is the reason why it's useful to have a standard kind of design format. So different tools can say, okay, we accept this standard design format. So what we do is some flows on some projects or in some companies, they are more a tickle based. They always take their inputs as at each stage as a tickle file. For example, they would create one tickle file that they will give to synthesis, they will give to place and route, placement, CTS, routing, and then for final sign off. Some groups, project groups or companies, they tend to use SDC files. So very first time they might have a tickle, but then in their flow, they just stay with the proper SD format. Every tool stays with that. Okay. SDF, that is standard delay format. Okay. This file contains literally the timing for every cell, every wire, interconnect timing arc. So basically, if somebody has this netlist, then later on they can read this SDF and back annotate on top of the netlist. They will get the same timing information that you have right here, right after synthesis. One obvious customer of this is the gate level simulation that maybe DFT team is running or RTL team is running. So on when they typically run on RTL, but RTL doesn't have all the delays, right? Arrival times, skew between different arriving signals and all that. So prior they were just doing a very idealistic, but Netlist has gates, has standard cells, and they have delays. So if they want to do a gate level simulation of the chip, that will take a lot of time though, because now we have all the delay information. But maybe in some critical stages, it makes sense to do that. Or maybe for smaller chips, we can do that. Or maybe in the DFT part, we can do that. Okay, maybe ATPG2, I haven't run that myself. Probably that needs it. So anyway, there are customers of SDF files. That's why we generate that. ScanDef file this is typically can be needed when we had a separate these two. This def file we would read here, so your PNR tool knows exactly how is the connectivity of scan chains, because it needs to make sure when it does the moves for the placement, it doesn't, like those stitch flaps together it's better for their timing, for their routability, that they stay close to each other. So based on the scan def information, they can make sure that overall design placement is more favorable for those stitched flip-flops together. Okay, I think that's it. Yeah, that's it. If you have any question, please write that in comments. Sometime I'm late, but eventually I will reply that. Okay, hope you like this video. Thank you so much. See you next time. Bye.